Let's break down what we just saw in the last video. Some of you may have used the data you gathered on the strobe video to calculate the acceleration due to gravity. But if not, this picture should show you how we can get that number. So this is a person throwing a rock, not throwing, dropping a rock off a cliff. Times 0, obviously the velocity is 0 meters per second. After the rock has fallen 1 second, the velocity will be 9.8 meters per second. After the rock has fallen 2 seconds, the velocity of the rock should be 19.6 meters per second, barring air resistance. 3 seconds, it's triple 9.8 at 29.4 meters per second. If I quadruple 9.8, I'll get the 39.2 meters per second. And finally, if I multiply 9.8 by 5, I'll get 49.0 meters per second. So for any time that I have for an object that is experiencing free fall, I can absolutely find out how fast that object is going. So let's take it for 6 seconds. So for 6 seconds, that's an S for seconds, I can multiply that by negative 9.8. I'm going to turn this to negative to remind myself that this is a vector quantity and the rock is heading downwards, and this is meters per second squared. Seconds cancel out. One of the seconds in the denominator here cancels out, and I get 6 times negative 9.8, or the rock will be falling with a velocity of negative 58.8 meters per second. And if I'm really correct about it with sig figs, I should have put 6.0 here, and then I would round this to negative 59 meters per second. So for any object in free fall, I can absolutely figure out how fast it's going at any moment in time by multiplying negative 9.8 by the time it's been traveling. So what does this mean? It means that an object experiencing free fall is a great example of motion in one dimension because the object is just falling down. Therefore, all 5 uniform equations of motion, 1 through 5, still apply to an object in free fall. All that needs to be done is the variable A no longer is a variable, turns into the constant of negative 9.81 or negative 9.8. And I've seen some textbooks say negative 10 as well. Your textbook uses negative 9.81. We've decided to use this one to be consistent with your text. So with all of this information and remembering the 5 uniform equations of motion, you should be able to try page 64, numbers 1 through 4, and we will go over these and stamp these off by the end of class on Wednesday. Have a good evening.